Thank you very much, Ramsey. Couldn't dream of a better introduction. So good morning. My name is Alain Durand. I'm from Comcast. I'm in the office of the CTO, and I'm the architect for this IPv6 project. So I'm going to talk about what do we need and what are our plans, and most important at the end, some of the challenges that we're facing. So to take a very, very simplistic view of Comcast, Comcast is a very big company. We have more than 20 million subscribers in the video world, more than 9-10 million in the high-speed data, and 1.5 million in voice and growing. So if you simply look at our video world, today customers have set-top box, and the set-top box is managed using a proprietary protocol called ALOA, nothing to do with Ethernet. And we would like to get away from this proprietary protocol and to go to IP. So do some simple math. We have 20 million customers. Each customer has an average of 2.5 TVs, so some are translated into 2.5 set-top boxes. And in the DOCSIS world, in the cable modem world, when you have a device, you always have two IP addresses, one for the modem and one for the device itself. So 20 million times 2.5 times 2, that's 100 million. And when I was asking the simple question, how can I get 100 million IP addresses? So some people from the registry around here maybe give me a simple answer. So in this simple picture, we have not talked about high-speed data nor voice. We have not talked about growth and acquisition of the company. This 20 million customers is actually much growing. It's more than 21, 22 million right now, and next step is expected to grow. So let's dig a little bit further. We used to use Net10 private addresses as in 1980 for the management of the cable modems. So the difference between the cable space and the DSL space is that cable modems are managed. They have an IP address. So typically the customer has one IPv4 private address for the modem that he will never see, and an IPv4 global address for his PC that the one he will see, maybe an address. The problem was that we exhausted that Net10 space in 2005. It's one of the very first documented cases where we simply did not have enough space. So we went to the registries. We used the largest pattern of Net73. We have renumbered all our modems from Net10 to Net73 and using Net10 in different places. But this is not really a sustainable path. I don't think that we go every 6 months to registries and ask for another /8. When we go into that? This is really for the control plane. We need to have visibility for all our devices. So putting a NAT box in the middle is not going to help us. We want to reach all these devices in one. So it seemed that to the company, IPv6 was clearly the solution. And don't blame this on me because they made that decision before the IPv. So we are starting now, and V6 is not going to happen overnight. So what is the driver behind all of this? Essentially, it's a lot of what people play is bringing to the picture. Last year, 2005, where we had only high-speed data, we had one IP address for the modem that was private, one for the home computer. So it's like one or two IP addresses depending on the account. Now we have this plus we have an ENTA. An ENTA is this adapter that goes in the phone line on one side and the cable on the other side. And an IP address for the ENTA, an IP address for its cable modem. So that, in most cases, makes now two IP addresses. Now we are going to have our set-top boxes that I was telling you about. So two IP addresses per set-top box. Two set-top box, or 2.5 set-top box per house. So we are going to go from essentially one or two IP addresses in the home to 8 or 9 or maybe 10, depending on how you count, IP addresses in the home. And that's a lot. And simply the folks on the 34th and 35th floor of my office building in Philadelphia were simply asking the question, is it better if I talk closer? So, thank you. So the folks on the 34th floor of the building at Comcast were simply asking, is there going to be a point where we could not add another customer because we ran out of IP address? And let me just tell you one thing, they were really scared of that. So, just a graph, it's not actual data, but close to, show trends. In The bottom of the graph, this is the natural growth of the number of subscribers that we have. And in blue, those are like the new services that we want to enable, triple play, quadruple play, and so on. And this is where the growth in IP demand is coming from. So what do we do? Well, we look at this and we say, we're going to V6, but V6 is not going to happen overnight. So we need contingency plans. So the first thing is to go to the registries and ask for more addresses. So we are going back. We will ask for some more until we get no for an answer. Maybe we push further up. The second plan for us is to use what I call the dark space, which essentially is pre-RC 1918 times where we use somebody's address space that is not advertised, and we will use it internally. This is all for management, it doesn't go outside. So as long as we can prevent things from leaking in or leaking out, then we should be safe. Or we could federalize a network, which is breaking down our large network into smaller networks. And this is really what we do not want to do, because we want to keep this global visibility of our entire network. So the plans that we started last year to do some planning. And what we want to do is to deploy IPv6 of the control plane. That means the management and operations of all the edge devices that we manage. It could be the DOCSIS cable modem, the set-top boxes, and at some point the packet cable MPAs. We are not talking at this point about offering IPv6 as a service to the home for laptops and things like that. That will come at some point, but right now there is no demand for that. So probably what we will do is that we will leverage our own infrastructure that goes to V6 and try to create at a further point some new services that will just benefit from V6, but that will be a side effect. Really, again, I really want to insist on this. We want to deploy V6 for the control plane and the management of our own devices. So some guidelines. Deploying V6 will of course be minimally disruptive. There's a real network in place, you cannot disrupt the revenue stream. We want to make sure that V6 is in the roadmap of all the next generation devices, DOCSIS 3.0 and others. Talking to all our vendors, we'll come back to this point later, to make sure that they have IPv6. And we need to make sure that our operations and our infrastructures and all our systems become ready to support IPv6 devices. And slowly that will come into our DNA. So, to the point, what does it mean? The architecture is to really have an IPv6 address on this cable modems in the set-top box. So we will have a core network that will be dual stack, IPv4 and IPv6. No tunneling, no transition techniques, just pure native IPv6. With the same links as that carries IPv4. But simple, that works, everybody has done that before. And we will have at the edges IPv6 only devices. That means that at the edges we cannot afford to have dual stack. If we had an IPv4 address, we will not need IPv6 in the first place. So at the edges where we have those millions of devices, it has to be IPv6 only. So the deployment approach will be from the core to the edges. So we'll go first on the backbone, then our regional networks, then on a CMTS, which is a cable modem termination station, that's a router on the other side of the cable modem if you want, and then the devices. And that's an incremental deployment. Don't want to touch it further. But one thing that is very critical is to follow the same operational model as in IPv4. We use DHCP massively in IPv4, but we do with DHCP exactly the same way in IPv6. And the user base from Slash on June 2nd. So we have recently lit a large part of our IP backbone, and we made sure that all the routers had an IPv6 address. And I asked some of our engineers to dump out the first IPv6 ping on 10 gig interface. It worked success rate 100%, that's nice. So you can see the details of the packet as I go request it to be applied. Funny thing is that for the very first IPv6 packets, we sent in our network and found a small little bit. But if you look at the TTL thing, you realize that the TTL of the packets which was sent is not the same as the TTL of the packet that was received. So there's some different colors we are trying to investigate right now. It's not just like So going back to this IPv6 only. So cable modems in DOCSIS 3.1 have a dual stack, meaning that the code will be ready to run IPv4 IPv6. So if this modem is on a legacy network, the CMTS that has only IPv4 may be configured with IPv4. That's the case on the left-hand side. If it is on a newer network that has IPv6, it will be configured only with IPv6. So the code is dual stack. The mode of operation is single stack. So there will be a layer 2 message on the DOCSIS channels because of the type for IPv6. When we look at all our back office systems, and it's mostly a white ticket problem again. We have to do an inventory of everything we have and try to see what the problem is. So we did this long and sometimes a nasty exercise. As for every single systems that we have, should this be upgraded to IPv6? So we ask two questions. The first one is this system going to communicate with a modem or set-top box? So new modems and the new set-top box will be IPv6 only. If that's the case, the system has to be upgraded to IPv6, and that's a major upgrade. Now, if the system is only talking to another system, not directly to the modem, there is no reason to use IPv6 as a transport. Absolutely no reason. So we will use IPv4. I will give you an example. So we have categorized all our systems into three buckets here. The one who need nothing, the one who need a very minor upgrade simply to display properly IPv6 addresses, and some who need a major upgrade to really have IPv6 functionality in them. And from 100 systems that we started with, 100 vendors, you could say, we had about 5 or 10 who needed a major upgrade, and 25 to 30 who needed a minor upgrade. So it's a much more manageable problem. So this is a picture that somehow explains how this works. In green, the cable modem on the left-hand side will be in an IPv6 only mode. The network in the middle will carry packet v4, v6, doesn't matter. The provisioning system will be dual stack, so we'll be able to manage and provision a cable modem, either a legacy one or a new one. But everything else in the back office will use IPv4 as a transport. For example, if I have an OSS stack that is going to get MIBs from the router, yes, the MIBs is going to include IPv6 objects in it, like the IP address of the interfaces, the number of IPv6 packets that will be sent. But there's no reason to use IPv6 transport to get that MIB. I can use any transport. I could even use IPX, AppleTalk, whatever, it doesn't matter. So I'm going to use IPv4 because that's what there is today. I will fetch the MIB through IPv4, and the MIB will contain some IPv6 object. All I have to make sure is that my OSS stack is actually able to display and input IPv6 addresses. So same thing for the different back office databases. I need to make sure that if you don't communicate to the cable modem, they will stay in yellow, meaning they use IPv4 as a transport. The payload may be AV6, the transport will be V4. So some of the challenges. Well, the first one is certification of equipment, because in a nutshell, IPv6 is still a very, very new technology. And the level of maturity of the implementation varies greatly. So some vendors have been doing V6 for 10 years, but we still have some problems. I'll show you one on my ping. Some of the vendors have nothing today, and they're going to rush and buy a third-party IPv6 stack, maybe add a third-party application on top of it, and I have to somehow expect that it work. So that's really a plug-and-play kind of exercise. So we're going to need to raise the bar for the level of acceptance of IPv6 product. That means formally explain what IPv6 means to the vendors. Because if we simply say there's a checkbox that says IPv6, it doesn't mean anything. Maybe they have seen an IPv6 packet in their life and they say, okay, we do IPv6. It doesn't work for me. So what I'm doing is I'm creating a list of RFCs that I really want this product to comply with. If it's a server, if it's a router, if it's a video server, if it is an operating system, it's a CMTS, it's different. So each of those products can comply with those lists. And then I need to have some kind of conformance certification plan against those different criteria. And today there's unfortunately not that much that I can really use. So that's an issue. Another issue is like training. Again, this is a very new technology. I'm trying to get some interns this summer to work with me, and they have never heard about IPv6. Maybe they have seen the keyword one day, but they have never seen a packet. They have never used a router or server with IPv6. So even though they are just coming out of school, they have zero knowledge whatsoever about IPv6. So every new hire that we get have usually 2 to 4 years of IPv4 experience, but zero in IPv6. So we have to have a continuous training process with some academic style presentations, hands-on experience, all kind of things. But this is going to be a major item. Vendors. So part of it is really to get all the different pieces together and put them together. So dealing a lot with the vendors, making sure that they have IPv6 in their roadmap, and not just as a checkbox, but as this list of RFCs which I've explained. So for some of them, it's a straightforward process. For some of them, it is a more difficult process. And sometimes we talk to a big vendor, and they have different products. Maybe 4 of the products have IPv6, but there's this other product that has been there, kind of lingering around, that nobody really cares about, that's not making a lot of money, but it's still critical for you. And this product may not have an IPv6 roadmap for the next 2-3 years. So that may become a huge problem. So in the provisioning system area, this is where we have the most issue right now. I was expecting this to be elsewhere, but this is what we run into. From an IPv6 protocol perspective, we run also into some surprises, especially with MIBs. At the beginning of the times, IPv6 working group at IETF has defined RFC 2465 as a set of MIBs for IPv6. A couple of years later, they decided that it was not a good idea, but they needed to have an integrated MIB that has both IPv4 and IPv6. Well, the reality of the implementations today is that most everybody implements very old MIBs that have only IPv4. Some OSS vendors implement the first generation of MIBs that was defined that has only IPv6, and some of the router vendors implement partially the new integrated MIBs, but only the V6 part of the new integrated MIB, and it's only partial. So if you put all this together, it just doesn't work. So it's a call for the vendors. There have been some new updated RFCs. When we say IPv6, we mean the latest one, not the one that was defined 5 years ago. So that's a real practical problem that we have. Some of the more internal questions. We used to run OSPF v2 for IPv4. We are looking at OSPF v3 or ISIS for IPv6. We're still in this long process to evaluate both. Probably well, going to v6, some have forced us to reevaluate our strategy in there. It has nothing to do with the quality of the protocol. It has to do with the quality of the implementations and the roadmap of the different vendors for both ISIS or OSPF v3. This is very different. And don't get confused with OSPF v2, OSPF v3. They share the acronym. That's about it. So, security. Well, we have v4 and v6, so we have a security policy for v4. So I can take the same security policy and instantiate it for IPv6. Is it going to be enough? I just don't know at this point. I simply don't know. I don't have an answer. So we're going to go ahead with that assumption that it is enough. Probably we'll run into some problems, and then we try to fix them. QoS is another one. So we have defined a number of code points for QoS users in IPv4. And I'm going to define exactly the same code points, use the very same code points, and use them for IPv6 QoS. Essentially, I'm going to make the assumption that the routers are going to drop packets not on v4 versus v6 criteria, but on this code point criteria. So if it's a packet in v4 that I have marked as important, it is as important as a v6 packet that I have marked as important. This is the same thing. My network has to be agnostic if it's v4 packets that are moving around or v6 packets that are moving around. So that's the assumption that I'm making right now, but it was not very clear simply by looking at the RFC if this is what we had to do or not, so this is our choice. So that's essentially it. I wanted to save some time for questions. This is not such a difficult exercise. Mostly it has been going through this inventory process, making sure that our vendors do the right thing and finding the biggest tick I can get to beating the vendors, and we will do it.
David Huberman from AIR. Without going into the specifics of Comcast, well, first off, that was a wonderful presentation. Thank you. Comcast is huge in the consumer's mind in North America. So if you go to V6, it's a very big landmark, I think. So we see all these things. You have to upgrade your back of the house, all the software. You have to upgrade your network. You have to upgrade this cable modems. You have to spend all this time retraining staff, training new staff. So the obvious question becomes cost. How do you sell what I have to imagine is a gigantic cost to move to IPv6 to the 44th floor, or whatever you say? Are you selling it to them, or do they sell it to you?
Well, they hired me to fix their problem, so somehow they are selling it to me. So they were when last year, or a year and a half ago, somebody came and says, well, we are running out of space, we are making this request to Aaron, we are not sure it's going to be accepted or not. They really went into panic mode. Because if we cannot get the addresses, that means that the business stopped growing. And whatever the cost is, this is essentially business continuity. You need to make sure that the business runs.
And the cost is non-negligible here, right?
It's not that big either. We're not talking about billions of dollars.
Okay. Thank you.
Lane. Russ Mundy over here. Hi. I had essentially a similar question, and it really was the upper management support kind of issue. This is certainly something that a number of us have heard in terms of not wanting to because it costs money to do this. And so I think from what you've described, there is an extremely strong business motivation reason for doing it in the case of Comcast. And I think this is a very good object lesson for others that may have some similar kind of situation. Because what specifically I was going to ask is, do you have upper management support? And clearly you do.
Yes, I have. And maybe the best way to describe how I have it is to say I must have an open door to all the upper management in all the floors in my building. I can see them almost whenever I need. It's actually easier for me to talk to those senior VP, executive VPs above than to talk to some of the engineers or some of the low-level managers. I get actually much more pushback from the low-level management than the upper-level management. But apply the right button, it will work. So this will clearly come from the top down.
Randy Bush, IJ. Oops, I'm sorry.
Steve Schultz from NASA. Do you have any plans to implement IPv6 multicast interdomain?
Not at this point. At some point we will have to bring multicast to the set-top box. So we have been looking at this and says, are we going to really have to carry V4 multicast in the core and V6 multicast in the core all together? If you know that we are running like gigabits of multicast per second in our core, this is not really a good solution for us. So we have been looking at things like making sure that we have only one stream of multicast. Today we have V4, so we'll probably keep it with V4. And if we need to have a V6 multicast stream arriving to a set-top box, somewhere toward the edges we will translate that V4 stream into a V6 stream, because we cannot afford the cost of running twice the amount of multicast in our network at this point. But so far this is again all for management, so we don't need interdomain multicast peering. We don't even need interdomain unicast peering, because this is mostly for internal stuff.
Doug Montgomery, you seem to highlight the need for certification and potentially profiles in what you plan to do with V6. Could you comment on whether you see the activities of the V6 Forum and the logo program as serving those needs, or envision something else?
I've been looking at the IPv6 Radio logo program, phase 1 and phase 2. This is certainly a good step in the right direction, but this is clearly not enough. For example, the V6 logo phase 1, phase 2 goes really deep into neighbor discovery and how to respond to different weird situations in neighbor discovery. So it's going really deep in that direction, but it says nothing about do you support MIBs. It says nothing about routing protocols. It says nothing about transport other than Ethernet. So it's clearly a step in the right direction, but we need to go above that, well above that. We're going to use this as a minimum entrance criteria for our vendors also. So if we have an operating system vendors, we're telling them you need to reach at least phase 1 now and phase 2 in a couple more, but that will not be enough. We will add further requirements to this.
But your plans are to do that through the forum and the existing facilities, or
We will
as
do
a private
that.
venture?
We will do that with whoever wants to do it with us. I've been talking to some privately to some other large ISPs who have similar interest, and we may do this alone with those guys or with the forum. We're open.
Hi, Medical Double Shot Security. So I had a question in terms of, we all know that sometimes vendors have some limitations with some of their IPv6 security or logging and auditing. And so since Comcast has a lot of dollars behind it, what has been the vendor reaction to you in terms of if you have some priorities for specific features that you need?
So far, we had a pretty good response from most of the vendors. Because, as you said, Comcast is a very big company. Nobody wants to lose Comcast as a customer. There are some instances where we need to raise the pressure.
Thank you.
The one, excuse me, the one comment you made early on was you're doing this with management because you're not seeing any demand, and I'm sure you're well aware that customers are never going to demand IPv6 because they shouldn't know protocol versions. Right, so how are you going to get to the point where you're supporting it to the consumer? What's the decision point for deciding it's more than just management?
It's a question of services. The way we look at our customers is what kind of service we can sell them. So now that we will have this V6 infrastructure in place, if some of our product engineering people will say, oh, there's this new service that I can create and sell to my customers and make money with it. And by the way, this thing will better work with V6, so we have this V6 infrastructure in place, so we will do it. That will be our criteria.
This is Sunil Patra from Juniper Networks. Alan, as you mentioned, you gave a good breakdown of why Comcast needs 100 million IP addresses. And if I understand it correctly, you're using IPv4 right now. So, do you use a pool of publicly allocated 100 million IP addresses? Are they all globally routable, or you use private IP addresses for this 100 million IPv4 addresses right now?
So we don't have 100 million right now. So we are growing toward 100 million. So we went away from private addresses because we didn't have enough. That's why we got Network 73. We're going to get more and more of those public addresses. So as long as we can use those public addresses, that's what we will do. And if this is not ready when the pool will dry up, then one of the plans, as I mentioned, is to use what I call the dark space, which is using other addresses that are not routed globally, but only internally. So we are never ever going to advertise outside, leak out those addresses. Don't worry.
Okay, so right now, can I ask you so 100 million is the future requirement, 100 million IP addresses. So right now, you are using dark space then?
No, right now we are using Network 73.
So that doesn't use IP? So I'm not familiar with what's Network 73 in general.
That's just public address space that was allocated to us by Aaron.
Okay.
So we try to do simple things. We have addresses that was allocated to us by Aaron, we are using it. And when we run out, we get some more. But at some point, they will say no.
Okay, thank you.
Bora Akil from Broadcom.
Can't hear you.
Hi, Bora Akil from Broadcom. You mentioned this also in the certification process, right? There's plenty to choose from, plenty of different RFCs that obsolete each other, etc. The other thing I wanted to ask is IPv6 is a very richly optioned protocol. compared to V4. Just think about neighbor discovery, which you mentioned. So how do you decide which options of, for example, neighbor discovery or any other IPv6 mechanism that you want to use? And are you going to publicize this to your vendors? Because if you just say RFC 2461 bis, or whatever the RFC number happens to be when it's an RFC, there's still like umpteen thousand options in there.
Yeah, I'm well aware of that. But there's an even worse than that. There are cases where there are two different ways of doing things, like DHCP v6 versus stateless auto configuration.
Exactly.
So in those cases, for the cable modem space, as I mentioned earlier, we are big DHCP fans. That's the way we operate our shop. People are very comfortable with it, and we're simply going to do the same thing. So that's the reason why we said for our cable modems, we don't want to see stateless auto configuration. Now, at the next level of granularity, this is a much more difficult exercise because I cannot tell you today which of the neighbor discovery options is going to be used and which is not going to be used. And my only choice is to say we need all of it.
Do you also plan on using a lot of the extension headers, etc., in your network?
No.
Okay, thanks.
Keep it simple.
Thank you.
Randy Bush, IJ, the two things that I note for is that A, continually goes back to what's the simplest way to get from here to there, and B, one aspect of that is don't try to convert the users. Right? He's just solving his network infrastructure problem. That's big enough.
Yes, it is.
But that's, he's not trying to sell V6 to the users and recover his cost then. He's saving money on his infrastructure. And that's, I think, what's key to making this a real winner for his company. Thank you, Alan.
Oh, one question from the corner here. Matt Peacock from Yahoo. So if you're going to be moving off of 73/8 or however big an allocation you got for it to use IPv6 for your infrastructure, are you planning on giving back net 73 when you're done with this?
When everything will be converted to IPv6 and there will be no need for IPv4 anymore, I'm sure that we will give it back.
Nice answer. Thank you.
Now, to be a little bit more specific, what I've described is valid in the context of managing our cable modem set-top boxes because they only talk to our internal systems. We will never ever see a Comcast cable modem sending an IP packet to Yahoo. Never. Well, if it is, it's really bad. So that works. But we have other things like our MTA, our phone systems, where we do voice over IP, where we do peering with other MSOs or other service providers. And at the end, our MTA is going to talk to another MTA somewhere else on the planet. And at this point, if you look at what packet cable is doing, packet cable 2.0 or based on IMS, and IMS is a SIP world that is very complex. And if you know how to make this interoperate in between V4 and V6, let me know, because I just don't. It's just too complex. So most probably we will save a lot of those V4 addresses just for that. Stay with V4 until we have a clean solution to do V6. Thank you very much.